Hello, I'm Dr. Stephen Green, and I'm going to talk about brain development and relate it to children with hearing loss. This work that I'm talking about comes a lot from the work of Dr. Daniel Siegel, who wrote a book called The Developing Mind and developed a new branch of science called interpersonal neurobiology. It's a new science that looks at how the mind and the brain, which are two different but inseparable things, how they interact through relationships to develop each other. So I want to start with a few facts about the brain. All living organisms have to adapt to their environments in order to survive. For human children, their primary environments are their home and their school. Survival requires that they figure out what is needed from their social relationships with their family and their educators. Our brains are the organs of adaptation. It's the organ of social engagement. Our brains develop in the context of relationships. Brains develop via experience. Good experiences in relationships develop a healthy brain. Bad relationships develop a brain with problems. Relationships are the most significant factors influencing child development. The majority of deaf and hard of hearing children have hearing parents. This causes significant challenges for the child and the family. Deafness itself creates other challenges to the developing brain, which I'll talk about in a bit. A significant outcome of child development is our self-regulation abilities. Self-regulation for a child over time includes the ability initially to manage their wake-sleep cycles, to control their bowels and bladder, muscle control in order to be able to sit, stand, walk, move their head, emotional control, attentional control, and behavioral control. All of these are examples of self-regulation abilities. Children who have difficulties during their period of development become dysregulated. It's said that their brains become dysregulated when they're in a stressful state. Examples of dysregulation include the inability to manage their deep primitive reactions and emotions, triggering the fight, flight, or freeze response, the inability to settle fear, anxiety, and anger. They have reactions instead of responses. They have an inability to sustain their attention and an inability to learn. What is developing over time during a child's development is an integrated brain system that results from connecting neurons. The more connections, the better the organism or the brain functions. So now I'm going to talk a little bit about our brain. Our brain is a complex system, and it's like any other complex system which are found in nature. Loads of examples of complex systems include large groups of fish or hurricanes, groups of birds where you see them all flying in an organized manner. All of those are examples of complex systems which are found in nature. And our brain is also a complex system. And complex systems share a variety of properties that all complex systems share. They are self-organizing, and they're inherently within themselves. They will organize moving towards greater and greater levels of complexity. They're comprised of many smaller parts that connect and integrate to become a more complex whole. They're open to outside influences, and complex systems that do not achieve greater and greater integration or greater complexity become chaotic and or rigid, versus systems that are more well integrated and more complex achieve what is called a phases flow. And that is, they're flexible, they're adaptive, they're coherent, so they make sense, they hold together, they have enough energy to achieve what they need to, and they're stable over time. One of the properties of a complex system, there's a process called emergence. And emergence is the way that complex systems and patterns arise out of a multiplicity of relatively simple interactions. So we have a whole bunch of these small little parts that organize together and become integrated, and they emerge and become what they're supposed to be, and resulting in a whole that is greater than the sum of its parts. And again, if the whole's well interconnected, it will become stable over time. So complex systems go through a process of emergence, and depending on how well integrated they become, they achieve a phases flow, flexible, adaptive, coherent, have enough energy, and they're stable over time, or they become chaotic and or rigid. And we see this in kids all the time. With less integrated brains, under stress, they become chaotic or really rigid. And I'll give examples later. So examples of chaos would include difficulties with intrusive thoughts, intrusive memories, hallucinations, constant worries, preoccupations, impulsive behavior, thoughts that distract the mind. And these brains have significant differentiation but no linkage. Examples of rigidity would include someone who shuts down, they're disconnected from their body, they're unmotivated, they may be depressed, repeated thoughts of an obsessive nature. They're not able to adapt to their environment or their situation. Examples of rigidity that we might see in school would be school refusal, shutting down, withdrawal, avoidance, and digging in their heels. Examples of chaos that we would see are acting out behavior, aggression, running away, screaming, destroying of property. Examples of a phases flow would be a child who's able to adapt to changes in their schedule, changes in their world. They can manage the disappointment when they run out of ice cream at lunch. They're able to adapt to what's going on without losing control, without becoming chaotic or shutting down and becoming too rigid. So when we talk about the brain, it's the embodied brain. The brain is not just what's up here in our head. It's also what's down in our body. The central nervous system is what we're talking about. We have as many neurons in our stomach as we do in the brains in our skull. So this whole system is interconnected. And so when we're trying to settle someone's brain, we want to work also with their body. The embodied brain, again, it's in the head and the body. And it's the organ that acts to sense, process, perceive, store, and act on information from the outside world and the inner world in the body to promote survival. The brain's number one job is survival. Everything that it does, first and foremost, is to assure survival and to respond to threats, either real or imagined threats, either physical threats or even psychological threats. So now I want to talk a little bit about the structure and the function of the brain. Really, the way the brain functions is more like layers, interconnected layers, but the triune model is a helpful way to envision and think about the brain. The oldest part of the brain is called the reptilian brain, and it's right at the base of our skull and connected to our spinal column and runs down into our body. And the reptilian brain can only do 6 things: fight, flight, freeze, submit, attach, and it regulates our autonomic functions, our breathing, our circulation of our blood. It's the oldest part of our brain, and really all it can do is react. It's always online. It's the earliest part of the brain to come online when we're born. Millennium later, our brains developed what's called the limbic system, or the emotional brain, and that's the middle part of our brain. And the emotional brain is for emotional memory. And memory is really critical because, again, the brain's number one job is survival. And it's really important for the brain to remember bad things. More of our brain is allocated to remembering negative things than positive things, because the negative things are the things that are going to kill us. And so those are the things our brain's more worried about, which is why we tend to hold on to things and remember bad things more than we tend to remember the good things. So the emotional memory in the limbic system is about memory. It's about recording the emotional strength of an experience. So really strong experiences, be they positive or negative, get recorded in the limbic system, and then it's available for the brain to call on later when it's trying to figure out, is this something good that I should go towards, or is this something bad that I should avoid? So the limbic system is involved with memory, the experience and expression of emotion related to arousal. It regulates thirst, hunger, and our mood. It's related to reward processing and movement and learning. Millennia later, the youngest part of our brain evolved, the neocortex and the frontal lobes, the executive function area. And while the primitive brain can only do 6 things, our executive function area can do thousands. It's where all of our higher function, planning, organizing, working memory, problem solving, predicting, all of that is in the executive brain. That's the youngest part of our brain to develop. That's the last part of our brain to develop. So, and that often doesn't develop until into our teenage, early 20s. Some people may be in their 50s. And so that's a time when, especially in adolescence, they don't really have a lot of frontal lobe. It's not well integrated yet. So issues like impulsivity, lack of problem solving, they're very disorganized. That's because the frontal lobe isn't online. So those 3 areas, those 3 major areas of the brain, the reptilian brain, the limbic system or emotional brain, and the executive or higher functioning brain. The complex system is working towards integrating all 3 of those so they will work well together. Ideally, when it's fully integrated, what happens is our brain 24/7 is scanning the environment, looking for threats, looking through at the outer world or the inner world, looking for threats. When the animal brain perceives a threat, it will alert, and it will get the system ready for a fight or flight response. In a well-integrated system, the emotional brain will evaluate what the animal brain perceived as a threat, and all of this happens in milliseconds. And then the higher brain will go through its files, will go through its memory and its experience, and if it determines that there's no threat, it will instantly down-regulate or settle the animal brain. So that fight or flight response will calm, and the system will go back to a relaxed state, and it'll just move on. In a not well integrated brain, the animal brain perceives a threat, it kicks into gear, and it takes over. And the higher brain may be saying, relax, there's no threat, don't worry, remember the consequences, you don't want to do this. But those 2 aren't able to communicate. The higher brain's job is to down-regulate the animal brain. But when it gets triggered into a fight or flight response in a not well integrated brain, the animal brain takes over and it runs the system. It's called emotional hijacking. And then the higher brain, the language centers, in extreme cases are offline. And so rationality, logic, thinking through a problem, predicting consequences, all of those higher brain functions, they're offline and they are not available until the animal brain relaxes, the brain reintegrates, the higher brain comes back online, and then it will calm the system, and then you have a more rational, reasonable brain with which to work. I want to talk a little bit about how brains develop. The self-organization of the brain, the self-organizing ability of the brain, It develops in the context of a relationship. Brains don't develop alone. Brains develop in connection to another brain. An integrated, regulated brain comes from interacting with an integrated, regulated brain. So a child who has a parent who's fairly well integrated, stable over time, doesn't have significant trauma, interacting with this parent-child will help develop this child's integrated brain. An infant or child who interacts, who have a parent that have trauma, addictions, attachment issues, problems in their own life that impact their ability to remain calm, who go through periods of chaos and rigidity, they're not stable over time, they create a young brain that is also dysregulated, not integrated, chaotic and or rigid. So integrated brains come from interacting with integrated brains, which is really critical to keep in mind in terms of us as parents and as teachers, that the more well integrated our own brains are, which we can work on ourselves to become more integrated, the more well integrated we are, the more we're able to influence children who are developing and to help them maintain more stable states of calm, as opposed to having chronic chaos and rigidity. There's an order of development in the brain. So the brain develops bottom up. So our spinal column is the first thing that develops, the neural tube, and it develops coming up, and then the right brain develops, and then it moves over to the left hemisphere and the left brain develops, and then the frontal lobe executive brain develops. So it's bottom up, right, left, back, forward. All the earlier levels of development, all the subsequent levels of development are dependent on the earlier stages. So when things go well from the beginning, along the way, subsequent areas of development also go well. If you have significant problems in the early stages of development, the foundation where the system's learning to regulate itself, then all subsequent areas of development are affected, which is really critical in terms of education and planning. If we have children who have significant brain delays or problems with integration, that affects all subsequent development, and that's going to affect their ability to learn, to be on grade level, to integrate new learning, to manage their emotional arousal, to manage their social relationships. It's going to have significant consequences along the way. And when we don't back up and work on those issues, on helping a child become more well-regulated, then their problems worsen, especially as the challenges and stressors and complexity of school increases over time. These kids start to have more and more and more problems. There's a gentleman named Bruce Lipton who wrote a really wonderful book called The Biology of Belief. He's a cellulobiologist. And he talks about the fact that we are cells. We essentially operate and function just like cells. All of our cells have like antennae that scan their environment looking for threats. They scan their environment to determine if there's a threat or if they're safe. And cells operate in a binary fashion, either open or closed. It's the only two ways they can operate. If a cell perceives safety, it opens up and it moves towards, it engages its environment, it grows, it expands, it interacts and engages with the rest of the system. If a cell perceives a threat, it shuts down, withdraws, and pulls away. We're essentially the same way. Our brain is like big cells. If we perceive safety, we move towards our environment. We engage with other people. We engage with activity and with the world. If we perceive threat, again, real or imagined, physical, psychological, emotional, if we perceive threat, we shut down, close up, and withdraw. And then we can't grow. Growth can only occur when we're in an open mode. A critical process related to how brains develop is what's called neuroplasticity. And neuroplasticity essentially says that our brains are plastic, that they change. They're not structurally really plastic, but they work like plastic. You heat up plastic and you mold it, and you can mold it into whatever you want. You can change it. Well, our brains interact with our environment, our inner world and our outer world, and experience changes the brain through the process of neuroplasticity. Experience stimulates neurons, which increase new connections, which increases more integration, which advances the brain towards greater complexity or greater integration. Good experiences change the brain in good directions, and bad experiences change the brain in bad directions. The good news of the story is that neuroplasticity happens right up to the moment we die. So we can have a lot of bad early experiences that will get wired into our brain. And then subsequent to that, later in life, we can have more positive, more healthy experiences, which will rewire our brain, create new neural pathways that will take us into a more positive direction. So the process of neuroplasticity is critical as it relates to learning and essentially changing the brain. Experience changes the brain. And through the process of emergence, the brain interacts with its environment and will organize itself. It will continue to develop, striving to move towards greater and greater complexity through more and more integration. So neuroplasticity experience changes the brain. The brain's trying to move towards greater complexity and greater integration. Good experiences will get us further along. Bad experiences will cause more difficulties along the way. Another really important process related to brain development, child development, is epigenetics. And epigenetics is the study of how our environment and our experiences influences genetic expression in one's lifetime. When we're born, the majority of our primitive functions are fight, flight, freeze, submit, and attach responses. They are online. They are functioning and working right from the get-go. The lower structures of the brain, the spinal column, the brain stem, the occipital lobe, which is connected to vision, all of that is online at birth. All the rest, the emotional brain, the higher brain, the whole process of integration, all of that occurs after birth, and it is experience dependent. Our brain has to have particular experiences in order for these genes to express themselves, to either turn on or turn off, depending on what they're supposed to do. If they don't have these experiences, the genes either won't turn off or won't turn on as they are programmed to do. So the system is set and ready to go, but they need certain experiences in order to stimulate the genes to, again, either turn on or turn off. So at birth, our brains are about 25% the size of our adult brains. By 3 years old, it's 80% the size of an adult brain. What's most important in terms of growth is not the amount of neurons, but the amount of connections that we have among the neurons. And those connections begin to form in a really critical way during the first 3 to 4 years of life. Brain growth and connections continue to be made throughout adolescence, but the majority of brain development and brain connections occur during the first 3 years. And again, if conditions are healthy, safe, secure, and appropriately stimulating, the brain will move towards healthy development by becoming fully interconnected or integrated. If the conditions are not healthy, or safe, or secure, or appropriately stimulating, then growth and neural integration will be negatively affected. When a child's born, their occipital nerves are online, and they have the ability to see. If you place an infant in a dark room and deprive them of any visual stimulation for a certain amount of time, before their occipital lobes have activated and those neural pathways have gotten established, that child will be blind. Their eyes work fine. The occipital lobes work fine. The problem is that they didn't have adequate stimulation and the connections didn't work. They weren't established. So you can have blindness caused by a deprivation of experience, a deprivation of stimulation. So epigenetics looks at when and what genes get turned on and get turned off based on experience or interaction with their environment. There are critical and sensitive periods of development. There's been debate and discussion, but you can see this with deaf children who are prelingually deaf. There are certain periods of time that, again, the brain needs particular stimulation. And if it doesn't get it during those times, there'll be a failure to develop. Different areas of the central nervous system are organized at different times, and they either require critical periods or they're most sensitive during particular periods to the organizing of the experience. They need certain neurotropic cues from the environment. The years between birth and age 7 are critical to visual development in children. Visual sensory deprivation during this time, as I said earlier, can lead to blindness. There's a critical period for the development of language. The critical period for connecting meaning to speech sounds is between 18 and 36 months, with a gradually diminishing ability to develop language that tails off at about age 12. Some of us have seen dramatic examples of language development beyond this point in time, but we've also seen loads of cases with kids that just don't develop adequate language skills who have been deprived for a decade in the early time of their life. There's a process, there are two rules in how brains function. Neurons that fire together wire together, and use it or lose it. So again, neuroplasticity involves the firing of neurons, making new connections. And so when neurons fire together, they will get wired together. You look at habits. So a smoker, they eat and then they smoke. Those neurons have gotten fired together repeatedly, so now they are wired together. And when you activate one, you're going to activate the other. So again, neurons that fire together wire together. If I have a repeated experience of failure in school, those neurons, the experience of coming into school, sitting in class, feeling stupid, feeling like a failure, those neurons will all wire together and will become a neural pathway. And now all I have to do is see the school, and I instantly move into a state of feeling like a failure and acting the way I always do when I feel like a failure. Maybe I avoid school, or I act out, or I shut down and withdraw. So neurons that fire together wire together, and they get connected. Another principle another process is use it or lose it. If you don't activate the neurons, the brain will prune them away. There's a process called pruning, which is where the brain determines that these neurons aren't needed. And it doesn't want to waste energy or sugar or space for neurons that aren't needed. The process of pruning goes on between 6 and 14 years old. where the brain, by about 6, we have all the neurons we're ever going to have. And then the brain starts to get rid of the neurons that it determines we don't need. So for a child with a severe hearing loss, whose language delayed, or a severe traumatized child, where their brain hasn't been exposed to language or hasn't had many experiences, their brain determines we don't need all these neurons. We don't need this part of the brain to function. And so it eliminates those groups of neurons. And in fact, the brain shrinks. If you look at the brain scans of a child with typical healthy development and one with extreme neglect, the child with extreme neglect, their brain is much smaller. As I said earlier, brains develop in the context of relationship. Attachment relationships are the most significant influence on the young developing brain. So all brains go through the process of pruning, where the brain, again, it eliminates neurons that it perceives are not needed, are not necessary. If you look at the brain scan of a child's skull and brain that has healthy development with a fairly safe environment where there's good stimulation, good experiences, exposure to language and to experiences that it can understand and that don't overwhelm it, it's a regular, typically sized skull and brain. If you look at a brain scan of a child who's gone through extreme neglect or severe trauma, their skull and brain is considerably smaller. And there are more dark areas in that brain scan because those parts of the brain didn't get wired. Early deprivation, neglect, trauma cause the brain to be smaller, to be less integrated, to be less capable of managing the world. And neglect isn't just the extreme bad cases that many of us know about. Neglect can be inadvertent, unintentional. For many children who have hearing loss and have hearing parents, or have deaf parents that grew up with hearing parents that didn't know what to do with them, many of these parents, without meaning to, they inadvertently cause the same situation of neglect that some traumatized kids go through. They don't know how to stimulate these children's brains. They don't know how to interact with them the way they do with their hearing children. They don't know how to read the cues, how to stimulate. They don't know how to see this child through a visual lens, which the deaf and hard of hearing child, more than not, their brain is a visual brain. It's not an auditory brain. They are oriented to the visual world, not the auditory world. And for many of these parents who are auditory based, they're hearing, and they are oriented to the auditory world. They don't know how their deaf and hard of hearing children's brains work. They don't know how those kids engage the world through a visual lens. They don't know how to present things visually. They don't know how to see things visually. They haven't been taught, and it's not natural for them to do that. They know naturally how to do things through an auditory mode. So without meaning to, these parents and educators don't provide these developing brains the kind of stimulus and experience and exposure that they need to activate the process of neuroplasticity, to create more neural connections, to create a more integrated brain that's able to function out in the world in a more flexible, adaptive, and stable way. Without meaning to, they deprive these kids of really critical stimulation and experiences that are essential to these developing brains. And without doing those early kinds of stimulation and experiences, over time, these kids have more and more deficits in thinking, in emotional control, in relationships, in problem solving, generally in functioning in the world. And often it's inadvertent errors. It's just people that don't know what's needed, and they don't know that they need to seek out resources from people who know deafness to know how to help this developing brain become all that it can be. So there's a study called the ACEs study, and it's the Adverse Childhood Experience Study. And it's one of the largest scientific studies of its kind. It had 17,000, mostly middle-income Americans participated. The focus was to analyze the relationship between childhood trauma and the risk for physical and mental illness in adulthood. Over the course of a decade, the results demonstrated a strong, graded relationship between the level of traumatic stress in childhood and poor physical, mental, and behavioral outcomes later in life. Early childhood experiences, early childhood relationships are critical to the developing brain and setting it off on a trajectory that's either going to be helpful or problematic in their life. One of the difficulties is the politicalization of deafness. That it says people who politicize deafness assert that deafness is not pathological, that it is cultural, that it is purely cultural, and it has no pathology, it has no negative consequences to it. Big D deafness is definitely cultural, but it also has consequences. Little d deafness, which many of our children who have hearing parents and aren't members or participating in the deaf culture, little d deafness is traumatic for many kids, and it has significant long-term consequences to emotional development that just cannot be denied and cannot be ignored. Relationships are critical to brain development. Survival is dependent on the ability of the child to communicate, bond, and share with others. Relationship skills have to be learned, just like every other skill. Language, reading, riding a bike, they have to be learned. And they are taught within the context of a relationship. Positive interactions in a relationship regulate the brain's stress response. Powerful regulating effects of healthy, familiar, supportive relationships protect the brain from the negative effects of chronic stress. Secure attachment relationships promote good health and protect the child from traumatizing effects of overwhelming stress experiences. There is a process, so what I described earlier about cells, and that our cells have antennas, that's called neuroception, the brain's perception of safety or risk. The neuroceptive state of safety is one that the brain wants to achieve so that it can be calm and open and engage its environment. When we're relaxed and safe, it allows the system to relax, and the whole being, the person, becomes receptive to interactions with others. Our challenge is to create a relationship-based state of safety so that neuroplasticity can activate the brain's natural process towards growth.